Okay, happy Thursday to all of you who took advantage of optional Thursday, right? It's required Thursday for us because we love the fundamental theorem of algebra, don't we? Yeah. Ashley, stop laughing. There's nothing funny about what I just said. We're serious here, right? Fourth hour is rubbing off on her. She's getting a little crazy. All right, so look at this polynomial off to the side there. Looks kind of crazy, right? What if I told you by the end of this period, you would be able to not only graph that, but you would be able to come up with the exact equation for it within a matter of about 20 seconds? Looks kind of ridiculous to look at, doesn't it? But we're going to make it super simple, I promise. And you won't have an assignment today. We just got a little bit of work, and then I'm going to hand out to your tests. Let's get ready. First degree polynomial. You know what those look like. They are lines. You good with that? Oh, got to slow down from lines? Holy cow. We're in trouble. Panic buttons. Second degree. It's like, he said he can't draw straight lines. It's kind of like all lines are straight, right? So, oh, okay, never mind. All right, we're operating in different galaxies now. Okay, second degree parabola. Third degree. Fourth degree. Oh no. It looks like the second degree, only it's weird. Mirrored. What's happening every time we add a degree? You add a bump. Very good. We could call them extreme points. This one has one extreme point. Does it have a maximum or a minimum? Minimum. This one has two extreme spots, right? A max and a min. The next one has three. The next one has four. Hey, look at it. Four extreme values, fifth degree. Three extreme values, fourth degree. Two extreme values. So if I had a sixth degree polynomial, how many extreme values could it have? 5. So if I had an n degree polynomial, how many extreme values could it have? N minus 1. Given a polynomial of degree n, there are at most n minus 1 extrema. And I say minus 1 at most because you could have even fewer than that. We'll get to what those shapes look like later on. All right. What's great about this unit is it all connects together so well, and it could just stay inside your brain. Watch how we're going to make this happen. Look at the polynomials. They're all positive, and they all end going which direction? Up. Do you see that? Forget about how they start. Think about how they end. They all end going up. Now I'm going to draw the negative ones. That'll be a negative parabola. That'll be a negative cubic. That'll be a negative quartic. That'll be a negative quintic. Kind of tough unless you got a different colored pencil, huh? Okay, you guys told me all the blue graphs are positive and they all end going up. All the green graphs are negative and they all end going down. So if it's positive, it will end up. If it's negative, it will end down. Everybody got that through their brain? Okay, now we're going to talk about where it starts. What do you notice about the second and fourth degrees? Focus on the even ones. What do you notice about the second and fourth? Compare their ending and their starting. Starts up. ends up. Starts down, ends down. Starts up, ends up, starts down, ends down. If it is even, it starts and ends in the same area. You see that? What if it's odd? Starts and ends opposite, right? Yeah. So we don't think about when we start graphing a polynomial, I never think about where it starts. I always think about where it ends first, and I work backwards. That seems to be the best way to think it through. If it's positive, it ends up. If it's odd, it begins in the opposite direction. If it's even, it begins in the same direction. Simple as that. Okay? Everybody got that kind of piece locked in? And we're going to go over again tomorrow. Trust me. We're going to do a ton of example problems tomorrow. Was that basic idea kind of in your brain? All right. Then we move on to this idea. If you notice, these polynomials may pass through spots on the x-axis. Wherever a polynomial passes through the x-axis, we call that a zero or a root. And we have different types of roots that exist. Whoop, don't do that. When a polynomial passes through and it has this type of shape, we call it a single root when it looks like this. Okay, when it passes through and it kind of just goes straight through without any change in shape, we call that a single root. When it has shape like this, we call that a double root. Can anybody tell me how we could remember that that shape produces a double root? Looks like a parabola. What do you think a triple root will look like? It'll look like that cubic type shape. Single root, double root, triple root. Using that idea, we could generate all sorts of sketches of polynomials. And because we're short on time, I'm going to hand back to your test. All I want to do right now is I want to generate this equation. So instead of giving you an equation and graphing it, which is what we're going to spend our time on tomorrow, we're going to take this graph. We're going to generate the equation super quick. Watch me go. What's the first x value passes through? So it'll be x plus 2. What kind of root is it? Is it a single root, double root, triple root? Triple. What's the next spot it touches? Single root, double root. Double. What's the next spot it passes through? Single root, double root, triple root. How about the next one? Passes through? Single, double, triple. I bet that produces the equation for the polynomial. That didn't take very long, did it? Look at the degree of the polynomial. 3, 4, 5, 6, 7, 8, 9. This is a 9th degree polynomial right there. Watch what happens when I plug it into my calculator. I plug it in just like that. And I change my window so that instead of being 10 by 10, I make the x value of -4, the y value, or the x value of +8, tick mark every 2. It looks like my y values go down to -50,000 and up to 40,000, and a tick mark every 10,000. If I graph that, it should produce it's no big deal for us. We could graph any polynomial. Not only can we graph it, we could graph it extremely accurately, super fast. No big deal. Nothing will hold us back. Good work. We'll carry on tomorrow with kind of the shapes that we produce, and I'll get your assignment tomorrow.